Hello everyone, welcome to today's stream. I hope you are all excited to review today's Leetcode contest 432, and I hope this is gonna be a fun and exciting session. So guys, before we'll start our stream. Going to the first question of today's contest: zigzag grid traversal with skip. The question goes this way: you are given an m cross n 2D array grid of positive integers. Your task is to traverse grid in a zigzag pattern while skipping every alternate cell. Zigzag pattern traversal is defined as following the below actions. Start at the top left cell, move right within a row until the end of the row is reached, drop down to the next row, then traverse left until the beginning of the row is reached. Continue altering between right and left traversal until every row has been traversed. Note that you must skip every alternate cell during the traversal. Return an array of integer result containing in order the value of the cells visited during the zigzag traversal with skips. For example, this is a 2 cross 2 grid, uh, and the input we are giving here is 1 comma 2 and 3 comma 4. But we have to get the output as 1 comma 4 because it has to skip the every alternate cells. So it will be skipping 2 and 3. Now going on to the second example given. Second example given, the grid is 2 comma 1, 2 comma 1 and 2 comma 1. So here in the first, when the first alternate cell is skipped, from the top left will start, first 1 will be skipped, and coming on to the next it will come to 1, so 1 will be present. Going on next, 2 will be skipped, and then 2 will be printed and 1 will be skipped. So I guess the question is here. This problem is a 2D grid and zigzag pattern. We have to skip every alternate cell and the traversal should start from the top left. We have to return the list of cells values with the values. For example, like we took this examples. Here 1 comma 4 will be printed ignoring 2 comma 3. So for this question, we can go with this intuition will gonna be like this. It requires us to visit every grid in like alternating between right and left directions across the rows. We should go across the rows, and additionally, every alternate cell must be skipped. This is gonna and for this we can use the approach by traversing row by row. We can go row by row traversing it and alternatingly appending the row and appending it in reverse order. So the zigzag pattern is gonna be achieved. Then we can use the final slicing approach so that we can result the list and alternate result will be skipped. Alternate number will be skipped, like the alternate cell will be skipped. We'll solve this question. Any of you like who are viewing and are interested to do can do together. We'll do this question. The It's already predefined class solution. The function name zigzag traversal with grid list as a list and integer list, and we'll go for the next one. We'll create a variable result, an array. We'll run a loop for I equal to n minus 1 and j equal to m minus 1 and a condition if, okay, sorry. For I comma r in enumerate grid result is equal to result reversing the array minus 1 if percentage 2 else r. Return result and again array. Guys, will add the comments for, sorry for the disturbance. We'll add the comments so that we can understand this easily. This is initializing the list, initializing the empty list. This is an empty list to store the result. This for loop, we are running it to loop through each row of the grid. I here is the index and R here is the row. So this loop is run, loop through each index index I and row R. And this line, the if condition we have given, if the row index is even, the row should be kept similar because it's a rightward traversal. And if not, then we have to reverse the row because of the leftward traversal. So here we'll give the condition if even rightward traversal, else reverse the row. If even, keep row as it is. And this is for returning the result. We'll run this. Okay guys, sorry. There's a small mistake. It's not result is equal to, it's result plus equal to. We'll try this again. Oh shit, there's a spelling mistake. Enumerate. Sorry for it. Mhm. Okay, guys, finally we got the output. Sorry, there were some mistakes. We'll submit it and check if it's correct. Okay, so it accepts. And the time complexity for this code will be the time complexity will be for traversal of the grid. Grid will have n rows and m columns. So, and the slicing of the result will also take the time. So the overall time complexity will be like O cross M cross N. And we'll go to the next question. The maximum amount of money robot can earn. Okay, going on to the next question. Maximum amount of money a robot can earn. You are given with an M cross N grid. A robot starts at the top left corner of the grid, 0, 0, and wants to reach the bottom right corner, M minus 1, N minus 1. The robot can either move right or down at any given time. The grid contains a value coins I, j in each cell. If coins ij is greater than 0, the robot gains that many coins. If coins I, j is lesser than small 0, the robot encounters a robber and the robber steals the absolute value of coins I, j coins. So that it will come to 0 there. If you reach the absolute value, the robot has a special ability to neutralize robbers in at most two cells on its path, preventing them from stealing the coins in those cells. And also, it is given that the total coins of a robot can be negative, We have to return the maximum profit the robot can gain on the route. We'll see the example what they have given. Input coins is equal to 0, comma 1, comma minus 1. And the second, it will be 1 comma minus 2, comma 3, 3 comma minus 3, comma 4. So for this, we'll consider the start 0, comma 0 where it is starting. And since it has like it has no coins in the start, moving to 0, comma 1, it will earn 1 coin. And then moving to 1, comma 1, here the robber will steal the 2 coins. But the robot can use one neutralization here and it can avoid the robbery. So the total coins will remain the same. Going on to next, moving to 1 comma 2, it will gain the 3 coins here. 1 comma 2. 1 comma 2, it will gain 3 coins. And then going to 2 comma 2, finally going to the right side, 2 comma 2, it will gain 4 coins. So 4 plus 4, the output will be 8. The output is gonna be 8 coins. This is returning the maximum profit it can get. The maximum profit a bear can get is 8 here. The robot can get is 8 here. So we'll start to solve this question. We can use a 3D DP table setup with DP, I, J and reminder used, where I and J will give us the current coordinates of the grid, and reminder will give the REM will give the remaining number of cells where robbers can be neutralized. And this will this DP array will store the maximum coins collectible from position I comma J, and this reminder REM will give the neutralization level. And in the starting, we'll have a base case where robot reaches the bottom right corner n minus 1 comma m minus 1. If coins I comma j is negative and the neutralizations left is greater than 0, the negative effect will be nullified because the robot can neutralize the effects. Otherwise, it will gain or lose the coins. The robot will either gain or lose the coins. Uh, we'll be using DP memoization. If DP I comma j comma reminder, so that it will reduce the time complexity, it will just increase the speed of execution. If DP I comma j comma rim has already been computed, it will return the value instead of calculating it again, so that it will avoid data redundancy. That's all basically. So we'll solve this question. Start. After the class solution class, we'll define one more function, diff help. Here self I comma j comma remaining comma n comma m comma coins and the DP. And we'll enter if I is equal to n minus 1 and j is equal to m minus 1. We'll just shift this max amount function a bit so that we'll have a clear space here. If I is equal to n minus 1 and j is equal to m minus 1, this is the base case. Here one more if condition. If coins I and j is is smaller than 0. This is the base case. We will return 0 if remaining value is greater than 0. Else, coins ij. Now going to the other cases. Else will return the coins I, comma j. And now if I greater than or equal to n or j greater than or equal to m will return the negative infinity. And if dp, now we'll use the dp array, I, j and the remaining rem is not equal to float infinity, will return the dp. I'll just zoom this so that it will be clearly visible. I'll maximize this. Will return the dp I, j and rem, which is remaining. And we'll write this. Right is equal to minus float infinity down is equal to minus float infinity. And here one more if condition. If coins I and j is greater than, sorry, is smaller than 0, if remaining value is greater than 0, right is equal to self dot help I comma j plus 1 comma remaining minus 1 comma n comma m comma coins comma dp. And now down is equal to self dot help I plus 1, comma, j, comma, rem minus 1, comma, n, comma, m, comma, coins, comma, dp. The only change here is here we are using I plus 1 and here we are using in the first condition it's j plus 1. And then we'll need the maximum we'll need the maximum profit. So for that, right is equal to max of right, comma, coins I comma j plus self dot help I comma j plus 1 comma remaining comma n comma m comma coins comma dp. dp I comma dp j dp of ij and remaining rem is equal to max right comma down will return the dp. Now we'll bring this function. Now here n is equal to coins, m is equal to length coins array starting with 0. dp is equal to, sorry, a 3D array with negative float infinity into 3 for I, sorry, for dash in range m. Next, for underscore in range n. Return the final return self dot help 0 comma 0 comma 2 comma n comma m comma coins comma dp array. We'll run this code. Oh, we had forgot our equal to sign here. We'll run it again. This is the same solution I had written just a few minutes before, and this is exactly what I just explained now. Sorry, we'll run this code. Now we will add the commands for this to understand this code better. The first one, base case, and you all know what the base case is. Base case is if it reaches the bottom right corner with the with the robber lobbing only the coins and the coins value is negative. And now like this is a very self-explanatory function actually up to here. Here we are just returning the coins and this infinity is used just to make sure that the negative values won't be giving a like time limit exceeded or the memory limit exceeded, those kinds of errors to avoid them. And to fit this value of this numbers, we are just giving this float infinity. This is initializing the variables to move like this is um, initializing the variables to move right as well as down. And this is when this current cell is having a robber. Current cell has a robber and neutralization is left. And I'll not write full neutralization. NUTZ, NUTRZN is left. And the next one, this is for without neutralization. Again, NUTRZN without neutralization. Now to store the values, we are using this return DT. We are returning it here. This is to store. This is to store the maximum collected coins. In this function, I don't think so. This is a basic recursive function, so I don't think so there is any need of explanation for this. Now we'll run this code and we'll submit the code. Okay. So this question will have a time complexity of O of n cross m cross 3 because of a 3D DP array, but the 3 there corresponds to maximum neutralization, which is either 0, 1, or 2. Since O of n cross m cross 3, we can simplify it into n cross m. The final time complexity for this will be O of n cross m. I hope this question is clear for all of you guys. Going on to the next question. Minimize the maximum edge weight of the graph. This is a very easy as well as typical graph question. Okay, we'll go for this question. First, we'll read the question. Minimize the maximum edge weight of graph. You are given two integers n and threshold as well as directed weighted graph of n nodes numbered from 0 to n minus 1. The graph is represented by a 2D array edges where edges of I is equal to a of I, comma b of I, comma w of I indicates that there is an edge going from a of I to node b of I with weight w of I. You have to remove some edges from this graph, possibly none, so that this satisfies the following condition. Node 0 must be reachable from all the nodes. Maximum edge weight in the resulting graph is minimized. Each node has at most threshold outgoing edges, and for this, we have to return the minimum possible value of maximum edge weight after removing the necessary edges. If it is possible for all conditions to be satisfied, we have to return -1. Here, for example, n is equal to 5. 5 is the and the edges are 1 comma 0 comma 1, 2 comma 0 comma 2, 3 comma 0 comma 1, 4 comma 3 comma 1, and 2 comma 1 comma 1. The threshold here is 2. The maximum value of output can be the threshold value. And here we have to go and we'll get the output as 1. We'll directly get this value. We have to remove the edge where it is going from 2 to 0. Even then we can go from 4 to 3, from 3 to 0, then from uh, 0 to 1 and 1 to 2. We can still go to all the edges. All the nodes are connected. And going on to the next one. N is equal to 5. Edges is equal to 0, 1, 1, 0, 2, 2, 0, 3, 1, 0, 4, 1, 1, 2, 1, 1, 4, 1. And threshold is equal to 1. It is impossible to reach from node 0 to node 2. And so I will have to return the output as -1 as per given condition. We'll solve this question. I'll go to the submissions. I have the question which I just did. We'll copy this to the editor. We'll go back to the description. To understand this question, okay, this is a graph adjacency list based question where G is used to represent this this G is used to represent G of I contains list of pairs representing the neighboring nodes and the weight of edges. This is the approach we are following. This is for graph representation. Then we'll initialize C and T to count the number of outgoing edges for each node so that it won't exceed the threshold. Then we'll use the BIS visit so that we'll mark the nodes that is visited and it won't be visiting it multiple times. And then going on to the next one, it's a priority queue which will be initializing here. So yeah, before that we have to construct a graph. For that we have to iterate over the given edges. This is the loops which we have written for that, these two loops. And also we have to sort the neighbors of each node in ascending order based on the edge weight. so that smallest edge weights will be considered first during the traversal. And after that, we'll construct the priority queue to so that we can um, process, which will help in processing the nodes in order of the edge weights given. So the maximum edge weights will be considered first. Priority queue, the maximum edge weights will be considered first. And now the fire traversal. This priority queue is now empty. So when it's empty, we'll dequeue the top element, which is the smallest edge weight. And then if node is visited or the edges exceed the threshold, we'll skip processing it. Or else, see, this is one. If it's once visited, that's all. And next, unprocessed neighbors of the current node to the priority queue. We'll add all the unprocessed neighbors to the current node of the priority queue. And finally, we'll check if everything is like final check and we'll return -1 if the conditions are not satisfied. Going on, we'll add the commands to understand this code better. Here we have used comparator in this program. A comparator will be used in general. In Java, we'll use comparator generally. Comparator is used when we want a sorting logic of our own, custom sorting logic for the objects, and we will specify how the object should be compared. In this case, this comparator is used to sort the adjacent list G of I by edge weights in the ascending order. This so that this will ensure that the priority queue will process the edges with smallest weights first, and so that by this way we can minimize the maximum edge weight in the graph. So first we'll start to add the commands for this listing. This is just initializing the graph and then initializing the counters, initializing counts and visited arrays, count and visited arrays. And now the first for loop after initialization. This is to fill the graph edges. And also to reverse the direction of edges. And this is sorting the edges. And here we have used comparator. It is very similar to one algorithm. Any of you guys who knows that algorithm? Okay, so this is similar to the very commonly used algorithm, Dijkstra's algorithm. Here we are gonna use a similar kind of traversal, which is used for Dijkstra's algorithm. And then here the while loop will start processing the priority queue, processing the graph using PROC, processing using priority queue. I'll just write it as PQ. And this is the very important thing here. Skipping. Skipping the ones already visited. Skip already visited ones. And already and the ones exceeding count, exceeding threshold. I'll just write T hold for threshold or TS hold. And finally, this is for returning, like this is for the impossible case. Sorry, guys. Impossible. Then we have to return one, return -1, sorry. And this is what we have done here. So finally, we'll submit our question, submit our answer. Okay, so this is accepted. We'll go to the last and final question of the day, which was actually very easy compared to the third question, but it was very tricky there. This question is a very typical example of how an easy question can fool us if we just do a small oversight. First, count non-decreasing subarrays after k operations. You are given with an array nums of n integers and an integer k. For each subarray of nums, you can apply up to k operations on it. In each operation, you increment any element of the subarray by 1. Note that for each subarray is considered independently and meaning changes made to be one subarray do not persist to the other. Return the number of subarrays that you can make non-decreasing after performing the, the most k operations. An array is said to be non-decreasing if each element is greater than or equal to its previous element if it exists. If it exists. Going on, the input, like for the first example, input numbers array is 6, comma 3, comma 1, comma 2, comma 4, comma 4. K is equal to 7. Out of like there will be 21 subarrays possible for this with the given values, and the ones which cannot be made non-decreasing after applying up to 7 operations. K is the number of operations are 6, comma 3, comma 1, 6, comma 3, comma 1, comma 2, 6, comma 3, comma 1, comma 2, comma 4, and 6, 3, 1, 2, 4, 4. So that the number of non-decreasing subarrays is 21 minus 4, which is equal to 17 and which is given in the output. We'll go the question which was solved a few minutes ago. Here is the code. Here we go. Okay. So we'll go for the infusion and approach. Firstly, we'll reverse the array here so that any of reversal of the array does not change the essence of the subarrays in the reversed array. We'll just proceed in the reverse order. And then we'll initialize result. We'll initialize result and this Q. Q is a DQ, and then we'll also initialize I. I is the starting of current subarray, starting index of a current subarray. And then we'll iterate through every array. For that, we'll use the for loop with j in range of length of the given array, which is array A. And there, if we will pop the element from DQ Q that are smaller than the current element A of J. And then difference between A of J and the elements being popped will be subtracted from the given from the subarray length. And after that, finally, after that, we'll adjust the sliding window approach. Here we will be using sliding window approach. And here, if k becomes negative, it means that we'll need more operations than required, so that the code we have to adjust the code, and we have to we have to adjust the left window of the code by incrementing I until k is non-negative again. So for this, if leftmost element in the DQ is I, then it's removed from the DQ. And now counting the valid subarrays for each valid window here, window I comma j, the number of subarrays that will be is ending at j is j minus I plus 1, which is here. And so finally, we'll be taking the result out. This is a very simple yet tricky sliding window approach question. It asks us to count the number of subarrays using a sliding window with a DQ. Where most of the people will get confused is while using the sliding window approach for this question. And here we'll run this question. Also, we'll add this is just initializing. We'll add the commands for better understanding. Initializing. I'll just move. Initialize. This is all like DQs and all the stuff. No need to like, it's all the basic stuff. And this is for array. I iterate the array and DQ, popping the element in DQ. And while this while loop, if we exceed the operation, that means k is negative. K is lesser than 1. Sorry, k is lesser than 0. We have to do this. And finally, this is the result. And now we'll submit this. And it's accepted. So the time complexity for this one will be O of n, where n is the length of array. Any like it's a an arrays question, so the best case time complexity will be O of 1, and if the first element itself is found in an array. But here, since we are considering many subarrays, the, the time complexity will be O of n, and also the space complexity is gonna be O of n due to the space used by the DQ here. And time complexity, n is the length of array. Each element is added and removed from DQ. So if n elements, it will be O of n, which is linear time complexity basically. I just forgot one point. The previous question. Oh, sorry. The previous graphs question. Where is it? We'll go to the problems list. Okay, we'll go to the solution and come over this. We'll go here. Yeah, this question. We'll go to this question again. Okay, guys. So this question, the time complexity of this question will be, we'll split it. For graph construction, the time complexity is gonna be O of E log E, where E is the number of edges, and sorting will also take O of E or E log E. And for priority queue, it will be O of E plus V log V, where V is the number of vertices. Each node and edge is processed mostly once, so the priority queue will take O of log V. So the overall time complexity here will lead to O of E log E plus E plus V log V. When we simplify this, this is gonna lead to O of E log V. Since edges are higher than vertices, generally holds in the graphs. Like E is always greater than V in graphs mostly. So the final time complexity for this is gonna be O of E log V. So I guess all the four questions of today's lead code contest were solved. I hope all of you enjoyed. And anyone is like having any kinds of doubt in any of the question can say in the comment section so that I would just try and explain that one part. Any of you guys having any doubts can ask me in the comment section. Okay, I have a few comments here. Atul Akila. Same bro, I hope it will be fun and exciting. Yes, bro, it's definitely fun and exciting to do competitive programming always. So guys, I think that's all for today's stream.